Hey everyone, and welcome. Today we're diving into one of nature's most powerful and I think most incredible artists, the glacier. I mean, these things are literally rivers of ice, and for thousands of years they've been the planet's ice sculptors, carving out mountains and valleys with a force that is just unstoppable. We're about to uncover a story that isn't written in books, but is etched directly into stone.
But first, let me ask you something. What do you think has the raw power to grind entire mountain ranges down to dust, but starts its life as a single delicate snowflake? You got it. A glacier. And that's the whole mind-blowing thing about them, right? This amazing paradox. Starting as something so tiny and fragile and becoming this landscape-altering behemoth. That's what makes their story so incredible. So, to really get a grip on their power, we have to travel back in time. The landscapes we hike through and fly over today, a lot of them are the direct result of these ancient ice sculptors, leaving behind a story we can actually read in the rocks right under our feet. Our story really kicks off during the last ice age. You can see here, about 20,000 years ago, we hit what's called the last glacial maximum. That means enormous ice sheets smothered huge parts of the northern hemisphere. It took another 8,000 years, until about 12,000 years ago, for the planet to warm up enough that these giants finally started to retreat. And when I say enormous, I am not kidding. It is so hard to wrap your head around, but in a lot of places, this ice was over a kilometer thick. Just try to imagine the crushing weight, the unbelievable pressure of all that ice. That is the kind of power we are talking about.
So the big question is, how on earth does something so massive even begin? How do you get from a light, fluffy little snowflake to a sheet of ice that's a kilometer thick? Well, it's a really slow but incredibly powerful transformation.
Okay, so it all starts with accumulation. Snow just keeps piling up year after year without ever melting away completely. As more and more snow piles on top, its weight starts to compress the layers down below, squeezing all the air out. That compacted snow turns into this dense, grainy stuff called firn. Then, give it a few decades, maybe even centuries, and that firn recrystallizes into that deep, blue, solid ice of a real glacier.
And once a glacier gets big enough, once it has enough mass, it starts to do something truly amazing. It flows. Yeah, even though it's solid ice, gravity starts pulling it downhill, kind of like a super, super slow motion river. But you'll see that how it moves really depends on where in the world it is. You know, it really just comes down to temperature. In the super cold polar regions, glaciers are actually frozen solid right to the bedrock. So they move incredibly slowly, through something called internal deformation, which is where the ice crystals themselves literally squish and shift past each other. But in warmer mountain areas, the pressure can actually melt the very bottom layer of the ice. This creates a thin film of water that acts like a lubricant, letting the whole glacier slide downhill much, much faster. That's called basal sliding. And this movement, this is where the real sculpting begins. A moving glacier is just a relentless force of nature. It's basically a giant bulldozer, scraping and carving up everything in its path. And it does this using two really powerful methods. So, the first one is called plucking. Remember that meltwater we just talked about? Well, it seeps down into all the little cracks in the bedrock underneath the glacier. When that water freezes again, it expands like a wedge. So as the glacier keeps shuffling forward, it literally plucks or rips these huge, loosened chunks of rock right out of the ground. Okay, the second process is abrasion. Now, all those rocks that just got plucked from the ground are stuck in the bottom of the ice. And as the glacier drags them along, they act like a massive piece of sandpaper, just grinding and scraping away at the bedrock below. This sandpaper effect is what scours, smooths, and even polishes the landscape. And what's so cool is that this process leaves behind incredible clues. Abrasion carves these long, parallel scratches and grooves into solid rock. They're called striations. And geologists can look at these ancient scars today and tell the exact direction a glacier was moving thousands of years ago. It's pretty much a fossilized map of the ice's journey. All right, so our glacier has been born, it's moved, and it's carved up the land. But what happens to all that rock and dirt and debris it's been carrying? Well, that brings us to the final chapter of its life story, the legacy it leaves behind. Honestly, the best way to picture it is as a giant conveyor belt. It's not just eroding stuff, it's actively carrying huge amounts of rock, sand, and silt across massive distances.
The official name for this is pretty straightforward: transportation. And this material gets carried in a few different spots on the conveyor belt. Any debris that falls onto the top from, say, a valley wall is carried on the surface. That's superglacial. Some of that stuff might fall into deep cracks and get carried inside the ice itself. We call that end glacial. And of course, all that gritty material doing the sandpapering is being dragged along the bottom. That's subglacial. So all of this stuff, this jumbled up, totally unsorted mess of giant boulders, little pebbles, sand, and clay, it all gets a special name: till. See, unlike a river that sorts everything out by size, a glacier doesn't care. It just throws everything together in one big chaotic mix. Which brings us to the final act: deposition. When a glacier flows down into warmer areas, its front end, its snout, starts to melt, and as it melts, it just can't carry that heavy load of till anymore. So it just drops it, all of it, right there. This big pile of dumped material is the glacier's final footprint, leaving behind a completely new and totally transformed world. From a single snowflake to a sculptor of entire landscapes, the life of a glacier is just such a powerful story. But it really leaves us with a pretty heavy question for our own time, doesn't it? As our planet keeps warming, and today's glaciers are melting faster and faster, what story will they leave behind for the people of the future? What will their absence say about us?